The absolute value inequality of the form, the absolute value of ax minus b is less than or equal to d, where d is greater than 0, is equivalent to the compound inequality and inequality, negative d is less than or equal to ax minus b is less than or equal to d. So let's look at some exercises that use this format and how we would solve them and graph their solution set. So exercise A is solving and graphing the absolute value inequality. The absolute value of 2x minus 6 is less than or equal to 10. So first, we can rewrite this as an absolute value, this absolute value inequality as a compound inequality with and, less than. So less than, we can have negative 10 is less than or equal to 2x minus 6, which is less than or equal to 10. You add 6 to both or all sides, so that's adding 6, cancels out with the minus 6 in the middle and adding 6 to give us negative 4 is less than or equal to 2x, which is less than or equal to 16. Then we're dividing everything by 2, which undoes multiplying by 2 to give us our final solution of negative 2 is less than or equal to x is less than or equal to 8. That means we have the compound and inequality where we're marking negative 2 with a closed circle, 8 with a closed circle, and we have everything in between. Here's another example. We have the absolute value of 3x plus 12 is less than or equal to 15. Now there's actually two different methods to solve this since 3x plus 12 has a common factor, so we can use that to our advantage. Let's see the first method where we don't rewrite the absolute value inequality. We just keep it 3x plus 12. So that would be negative 15 is less than or equal to 3x plus 12, which is less than or equal to 15. We'll subtract 12 from all three sides, which leaves us with negative 27 is less than or equal to 3x, which is less than or equal to 3. We'll divide all three sides by 3, undoing the multiplying by 3, which leaves us with negative 9 is less than or equal to x, which is less than or equal to 1. So we're marking negative 9 with a closed circle, 1 with a closed circle, and we have everything in between. Now that's the first method, very similar to exercise A. But the second method is to think of 3x plus 12. You can factor out a 3, leaving us with 3 times x plus 4, and it's less than or equal to 15, that absolute value. And then we can use absolute value properties to take out the factor of the absolute value of 3 of 3. So we have 3 times x plus 4 is less than or equal to 15. And if we divide by that 3, that's where they're getting the absolute value of x plus 4 is less than or equal to 5. You can then create the and inequality now, where you have negative 5 is less than or equal to x plus 4, which is less than or equal to 5. And if we subtract 4 from all three sides, we end up with the same compound inequality. Negative 9 is less than or equal to x, which is less than or equal to 1. So just two different methods because of that common factor with our absolute value. Here's another example that has two different methods. We have the absolute value of 10 minus 2x is less than or equal to 26. So in this one, we don't rewrite anything. We just automatically split into our compound inequality where negative 26 is less than or equal to 2x minus 10, which is less than or equal to 26. We're adding 10 to all three sides, which leaves us with negative 16 is less than or equal to 2x, which is less than or equal to 36. If we divide everything by 2, all three sides by 2, that leaves us with our answer of negative 8 is less than or equal to x, which is less than or equal to 18. We're marking negative 8 and 18 with closed circles on our number line, and we have the shading in between. Now, 10 minus 2x has a common factor. Actually, we can of the first factor it has is negative 1. So they're just switching the terms around. They're factoring out a negative 1, and then the absolute value of negative 1 is 1, so it doesn't get written. So 10 minus 2x is this absolute value of 10 minus 2x is the same thing as the absolute value of 2x minus 10. That's one property. Then they're factoring out a 2. So we can use that property where the factor comes outside of the absolute value, because then they can divide by 2 to get rid of it, or have it simplify to 1, so that we have the absolute value of x minus 5 is less than or equal to 13. We then have our split, where we can say 5 minus 13 is less than or equal to x, which is less than or equal to 5 plus 13, which arrives us at the same answer, or the same inequality as the first method of negative 8 is less than or equal to x is less than or equal to 18. Now let's look at not less than, but greater than the distance. We have the form the absolute value of ax minus b is greater than or equal to d, where d is greater than 0, is equivalent to or inequalities, where you have ax minus b is less than or equal to negative d, or ax minus b is greater than or equal to d, which if we solve or keep simplifying, now we add d, we get ax is less than or equal to b minus d, or ax is greater than or equal to b plus d. This is the graph on the number line, where you have this idea if you divide by a to get x completely by itself, you get b minus d over a, and you have b plus d over a. And x is going to equal b over a. Here's an example, some examples with numbers, where it's not just an a and a b and a d, so it's a little less confusing. It's a little clearer to see what we're saying. So we're using, again, the absolute value of 4x minus 6, and now is greater than or equal to 20. And again, there's two different methods because 4x minus 6 has that factor. Let's say we don't use the factor, we just automatically split with our or inequality. So 4x minus 6 is less than or equal to negative 20, or 4x minus 6 is greater than or equal to 20. We can first add 6 to both sides, and then we're dividing everything by 4, which leaves us with x is less than or equal to negative 7 over 2, or x is greater than or equal to 13 over 2. We're marking negative 7 over 2, 13 over 2 with closed circles, and then we have our or, we have our shading in the opposite direction. This is the same thing if we also first factor out of 4. So to kind of get rid of the coefficient in front of x. So if we factor out of 4 and then use our absolute value property to remove it from the absolute value, and then divide by the 4, we end up with a new absolute value inequality, or an equivalent one, of the absolute value of x minus 1.5 is greater than or equal to 5, which we split with our or inequality. And if we add 1.5 to all sides, we end up with the same answer, same solution of x is less than or equal to negative 3.5, the same thing as negative 7 over 2. And x is greater than or equal to 6.5, the same thing as 13 over 2. Here's another example where we have the absolute value of 4 minus 5x is greater than or equal to 3. So greater than, it's going to be an or compound inequality, but the first method is just rewriting 4 minus 5x as 5x minus 4 using that absolute value property, and then splitting into our or situation and trying to solve. So we're adding 4 to both sides there, and we're using that distance fact, and we end up with 5x is less than or equal to 1. If we also add 4 here, we get 5x is greater than or equal to 7. So we have to divide everything by 5, kind of showing you the in-between steps. And we have x is less than or equal to 1/5, or x is greater than or equal to 7/5. Sometimes on number lines it's a little hard to see where those fractions are, so we're just converting them to decimals. You can divide 1/5 to get 0.2. Divide 7/5. 7 divided by 5 is 1.4. So with that or inequality, we have less than or equal to 0.2. So we graphed 0.2 with closed circles and shaded to the left. And we have 1.4 graphed, marked with a closed circle, and everything shaded to the right. This is the first method. All we did was rewrite 4 minus 5x as 5x minus 4. Now here, we are factoring out a factor of 5. We are creating a to be 1. So we have 4 minus 5x. We're still rewriting it as 5x minus 4, but we're dividing by 5. And we're taking that out of the absolute value to have 5 times the absolute value of x minus 4/5 is greater than or equal to 3. Now, if we divide both sides by 5, we get the absolute value of x minus 4/5 is greater than or equal to 3/5. So this method, number 2, you're using fractions a lot more in the process, but that's okay. It's just what you're more comfortable with. It's just a different way of seeing that if you now split into your compound inequality, you have x minus 4/5 is less than or equal to negative 3/5, or x minus 4/5 is greater than or equal to 3/5. If you add 4/5 to all sides, to undo the subtraction, you end up with x is less than or equal to 1/5, or x is greater than or equal to 7/5, which again is 0.2, and then we have 1/4. So we are, or 1.4, it's that same graph. So this second method is using a lot more fractions than the first. It's either if you want to split immediately into the compound inequality or use factors to rewrite that absolute value statement or expression. So it's really your preference. You can see both get you the same solution and the same graph.